Okay, so this is the second half of lesson 1 for our new unit. And before we were talking about the equation of a circle when it is centered at the origin. Okay, so that means we're always going to use this formula, x squared plus y squared equals r squared, when we have a circle with the center at the origin, at the point 0, 0. And then r is going to be the part that changes. And x and y are still going to stay x and y. But now it happens that sometimes we have circles that are not centered at the origin, like in exercise 3. We have a circle and the center is going to be at the point 3, 2. So that means it's not at the point 0, 0. It's going to be somewhere else. And it's going to have a radius of 6. So that's going to be enough information for us to actually figure out the equation of this circle. And we're going to use the distance formula to figure that out. So what we're going to do is we're going to start with a random point on the circle. I'm going to put it right here, and it's x, y. I don't know what the x value is, I don't know what the y value is, but any point on the circle can be written as x, y. And we're going to use the distance formula to find the equation of the circle by doing this. We know that the distance between these 2 points has to be 6 because that's going to be the radius. So it doesn't matter where I put x, y. I could have put it up here, I could have put it down there. It doesn't really matter because wherever I draw it, the radius is always going to be 6. So if we were going to do the distance formula with those 2 points, okay, the first point being the center and the second point just being x, y, then we can do the distance formula, but we're going to already know that d, the distance between the 2 points, is actually our radius here, and that's going to be 6. And then our other points that we've got, if we plugged into our formula, we're going to put x2, which is x, goes here, x1 will be 3, and then same thing for the y values, we've got y minus 2. And what's important about that is that in our equation that we have here, whenever you have a random point, that's always just going to be x, y. The parts that are going to change is going to be what the center is. So 3, 2 is the center, and the radius is on the other side. But we don't like that big square root for this because that is, it's too much to put as our equation here. So what we're going to do is we're going to get rid of that square root. And the way we're going to do that is to square it, and whatever we do to one side, we do to the other. And then that same equation can be written like this. So I'm just going to switch the left and right side. So it'll look like this. And that will equal 6 squared. Okay, or you could write 36 there. But I'm going to leave it as 6 squared because that'll show us what the radius is. It shows us that it's 6. And this will now look really close to the actual equation of a circle. So if we had the equation of a circle, whatever goes in this spot and this spot will be the x and y value for the center of our circle. So it says it's HK here, but if we look at our example, we have 3 and 2, which was our center for our question. Okay, one of the things that is a little bit confusing is that there's subtraction in here. So even though it looks like this says -3, it's not -3, it's minus a +3. So when you are writing your center, it's always going to be the opposite of whatever it looks like here, okay? Because the formula that we've got is x minus h squared plus y minus k squared. And that's going to always equal the radius squared. So you can see it written like this, or you could even see it written the same way, but with 36. Okay? And if you see something that looks like this, you could say, oh, by looking at this, I know that the center is going to be the point 3, 2, because the 3 is here, the 2 is there, and the radius is going to be the square root of 36, so that's going to make it 6. We know it's the square root of 36 because this piece of the equation is r squared. So another way of looking at it is r squared equals 36. Then you go ahead and try and solve for r. Okay, and it's pretty straightforward once you get used to how the equation is set up. Okay, so that is how you would use the distance formula for this. I do want to mention though what it would be like if we did Pythag for it. So if we turn this into a triangle like this, and we had that triangle and we wanted to do Pythag for it, this is what's going to happen. If we're going to do a squared plus b squared equals c squared, then this would be c, this could be a, and this would be b. And the way we would figure out the length of, let's start with a. The way we find out the length of a is we would have to say whatever this x value is, this whole length, and we would have to subtract this piece because we only want from here to here. So this whole length here is the x value for our random point. So we're going to do the x value minus 3 because our center point is over 3. And then we do the same thing for b. So b is this high minus this piece. So that is going to be y minus 2 here. So b is y minus 2. And then we already said that c is our radius. So if we did Pythag for this, we would have a squared, so x minus 3 squared, plus b squared, y minus 2 squared, equals c squared, which is the radius squared, and in this case, that's 6. That is the exact same thing as this that we did over there. So this is just another way of showing that the distance formula and Pythag is the exact same thing, and no matter how you do it, you're going to get your equation to look like this whenever you're trying to find the equation of a circle. So now let's use this. Okay, now that you know the fact, we're going to do some practice with it. And we're going to try and figure out 2 things for each of the following equations. We're going to try and find the center and the radius. And for our radius, since the equation gives us the radius squared, we're going to have to take the square root of something. So we might have to put things in simplest radical form. So this is how we're going to get started for this. One piece of it can sometimes be a little tricky. If we look at part A, see how x squared doesn't have an extra piece in it. There's nothing added or subtracted. So that really means that we have x minus 0. Okay, so if that helps you out, then you can throw that in there. Oops, 81 squared. And that will help us come up with our center. So our center of our circle here is going to have the x value be 0 and the y value be 1. Okay, remember in our equation, it's x minus h and y minus k, and the center is hk. Okay, don't make it -1 because it's not -1. It's a positive k here when this is being subtracted, so you're changing the sign. So our center comes from the left side of the equation when we've got it set up like this, and our radius is going to be, oops, I put a square here. I didn't mean to put a square there. Okay, our radius is going to come straight from this piece. So 81 is r squared. So we've got r squared equals 81, and we're going to solve for r that way. So we're going to take the square root of both sides, and r equals 9. Okay? You can show that work if you want to, but you could also see this part and just be like, okay, r equals 9. You don't have to do the work as long as you know how you got there and you could explain why 9 is the correct answer. So going down to B, we're going to do the same thing again. The center is going to be the x value comes from the x's. The y value comes from what's subtracted from y. And then the radius is going to be the square root of this number, and the square root of 1 is 1. For C, we have y here, which is really y minus 0 squared. And then we can get our center from both pieces. Now, this time we've got x plus 5. So that means that we really have x minus a negative 5. Okay? So our formula here has x minus something. So the y, or the x value for our center, is going to be whatever we're subtracting from x. So we're subtracting a negative 5 here. So negative 5 goes here, and 0 goes here. Again, if you don't like the idea of the subtraction, you can just change the sign of whatever this is to go in that first spot. Okay, we did that for these other ones too. This is negative 4, so it becomes positive 4. Negative 3 becomes positive 3. Or you can think of it as whatever number you're subtracting. And then, again, this part is going to be r squared. So that means that we're going to have to take the square root of both. And the square root of 40 can be split into the square root of 4 and 10. And we're doing this because it asked us to. And that's going to be 2 times the square root of 10. And then our last piece here, we have our center to be negative 1, because it's going to be a subtraction, or subtracting negative 1, or you do the opposite of whatever it says in the parentheses. And then 6 for the center. And then again, with our radius, we're going to have the square root of 72. And you're going to put that in simplest radical form as well. So I know we did that a long time ago, but if we looked at the first one that we have over here, you can split it into any two numbers that multiply to the top one that we've got, and then you reduce it down. And if you reduce it down and there's still more that you can split the number into, then you keep going. So like this one is 10. There's no perfect squares that go into 10, and the perfect squares are, we start with 2 squared, which is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So there's none of those numbers that can go into this. But if we were going to do the square root of 72, and I knew that 9 went into it, then I can split it into the square root of 9 and the square root of 8. And then I see 8 and I say, oh, I know that 4 can go into 8, so I'll just do this process twice. So I have the square root of 9, which is 3, and then I'll split 8 into 4 and 2. So I now have 3 times the square root of 4, which is 2, times the square root of 2, and we get 6 square root 2 to be our radius. Okay, so that is basically what you're going to have to do with these circle equations. And there's some other things that you can do with these. So sometimes they don't just give you the equation and you have to figure out the circle and radius. Sometimes they give you other information and you have to determine the equation of the circle. So let's take a look at this question. It's asking us to determine the equation of the circle when we're given the endpoints of a diameter. So we know that if we're going to find the equation of a circle, we need two things. We need the center and we need the radius. And they gave us the diameter. So we can figure out what the center is by first taking a look at what these points are going to look like. So if we had our circle and they gave us 2 points, we know that the midpoint of the diameter is going to be the center of the circle. We never talked about that in class, but that's something that you guys can figure out on your own. You know, just thinking about what you know about what a diameter is. You know it goes through the center of the circle, and both halves are going to be the same. They're both going to be a radius, and all radii are congruent. So that means the midpoint of the diameter is going to be the center of the circle. So our first thing that we're going to do is we're going to try and find that midpoint. But then the other thing we need to do is find the radius. So to find the radius, we're just going to need the distance between the center and one of our points. So our plan here is we're going to find the center and the radius first by finding the midpoint to get the center, and then we're going to use the distance formula or the Pythagorean theorem to find the radius. Okay, those are things that you guys can do. We're pretty used to doing those things by now. And once we have the center and the radius, then we can plug into our formula. And the formula we're plugging into is this one. Okay, we're just going to do this process that we did here, but backwards. So instead of having the formula and coming up with the center and the radius, we're going to take them and we're going to plug it into that format. So to start, we're going to do the midpoint. So the midpoint of these 2 points, we would use the midpoint formula. So to find the x value of the midpoint, you're going to do half of the x values added together. And to do the y value of the midpoint, you do half of the y values added together. So if you take a second and pause the video, just plug those in. Make sure you get a whole number for these. It's not always going to be a whole number, but in this case it will. So try it out on your own first, and then unpause the video and see if you got it right. Okay, so if you pause the video, then you should have gotten this as your x value. You should get 6. And then your y value should be 9. So that means our center, the center of our circle, is the point 6, 9. And then now we're going to do the distance formula between the center, which is the one that we just found out, and we're going to use one of the points here. So it doesn't matter which one you use. For me, I chose the second one, 10, 12, and 6, 9, and I plugged those into the distance formula, and then I got the radius. So again, if you want to take a second and try it on your own, make sure you get the correct answer, and then unpause the video and see what you get. All right, so the distance between the center and a point on the circle is 5. And remember, D stands for distance here. It's not standing for diameter. So if you want to rewrite it, the distance between the center and a point on the circle is actually the radius. So the radius is 5. So now we have both the center and the radius, and now we can plug into the formula. So our formula is set up, again, it's set up like this. So we have x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. So we're going to do x minus something squared plus y minus something squared equals r squared. So the x value of the center is going to go in this spot. So we've got 6 going here. The 9 goes in the y value section. And then the radius goes on the other side, which is 5. So we could leave it like that, or we could write the exact same thing. Exact same thing, and write 25 here. And that works too. We're not going to take these pieces and multiply them out because it's just going to make it more complicated for us for right now. We'll talk about when we need that in the next lesson. but for right now, leave them like this. So for the last question, we're going to do the exact same thing, except now I'm going to do it without doing all of the formulas. We're just going to look at the graph and come up with the equation. So again, we're going to need the center and the radius. And if you wanted to do this the same way, you can pick out two endpoints of a diameter and find the center of it, which you can tell probably just by looking at this that the center of this circle will be right here. If you have a hard time trying to find the center, then find the midpoint of the diameter and go from there. So the center is going to be the point 3, -2, and the radius, if we count how many boxes it takes to get from the center to the outside, that is 5 boxes. So we're going to plug into our formula. We're going to have x minus the x value of the center plus y minus the y value of the center is going to equal the radius squared. So the x value of the center is 3. The y value of the center is -2, so that means we're going to do plus 2 here. And then we've got 5 as the radius. So again, if you wanted to, you can change that 5 squared into 25. And that is the equation of this circle. So that's it for lesson 1. You have the lesson 1 homework to do. And what I want you guys to do for it is you have a couple options. Here's all of the questions in case you can't find the PDF of this on Google Classroom. But if you have access to the PDF that I posted on Google Classroom, you should be able to find every single lesson and all of the homework pages. And you can choose if you want to print out the homework pages and, just write your notes on there, or write your homework on there and take a picture of that and submit that. Or you can print out just the lessons that we're doing and, do the same thing, take a clear picture of it and submit it. Or what I'll let you guys do is use Kami and edit the PDF right on your computer. But when you do that, you have to make sure that you're showing enough work. So I've shown you guys how much work I want to see for each of them. So for some of these, you don't need a whole lot of work, but I want to make sure that you know how to get to each of these. So if you had a question that was like this, I'd want to see what you're plugging in, at least, and what your answer is. Okay, so if you were doing this one, make sure you have whatever you plug into your calculator for both pieces and whatever your answer is. So if you write it on Kami, you can do that. If you don't like any of those choices, you could also just write it on loose leaf. You could write it on a piece of paper, and as long as you're clear on what problem you're doing, then you can, just take a picture of that and send that in as well. Okay? I also post on Google Classroom a Google quiz, which was another way of me, collecting data about your homework. And if you guys like that way better, maybe I'll do the homework for this unit through there. That way you can just type it. But I need your input on that. I need you guys to let me know if that's something that you would want to do or if that is more confusing for you. Okay? So again, this is your homework for this lesson, and I'll see you guys in the next one.